Science Explorers, welcome to another exciting lesson in science. This one is called Balloon Rocket Science, and we're going to be discovering Newton's laws of motion. So Sir Isaac Newton, he was a famous English scientist, and he's known for the discovery of 3 principles of physics that describe how things move. These principles are fittingly called Newton's 3 laws of motion. And today you are going to be able to explain and give examples of each one of these 3 laws of motion. We're also going to test them out making balloon rockets. So let's look at what Sir Isaac Newton's first law says. It says that an object at rest tends to stay at rest, and an object in motion tends to stay in motion unless acted upon by an outside force. So I have a challenge for you right now. Right here, I have my document camera, and you need to make this document camera move, but you can't use your hands, your feet, your head, or any part of your body. You have to move it with just your minds. It's going to take some real great concentration. So make sure that you really focus on this object. Okay, on the count of 3. Ready? We're going to focus our attention, me too. And we're going to yell, move. And at that point in time, it's going to move. Ready? 1, 2, 3, move. Well, it didn't move this time. I want everyone to really, really concentrate. And on the count of 3, let's yell move as loud as we can, and we're going to try to get this document camera to move. Here we go. 1, 2, 3, move! Okay, so it still didn't work. Do you know why it didn't work? Yeah, it's because of Newton's first law of motion, which states that an object at rest wants to stay at rest. This also means that an object in motion wants to stay in motion unless a force acts upon it. So think about those forces, a push or a pull, right? So this object is at rest and it wants to stay that way. But if I give it a push or I give it a pull, I can make it move. Another term used to describe Newton's first law is inertia, which is the tendency of an object to resist change in motion or rest. You've probably felt inertia before. Think about a time you were traveling in a car and all of a sudden you had to stop quickly. What did your body do? Even though your car stopped, your body kept traveling forward, right? Because if we're traveling in a car at 55 miles per hour and it makes a sudden stop, our bodies are still in motion. They want to continue to move. The force of the seatbelt is what stops us. So now that we know about Newton's first law, let's move on to his second law. The second law states the greater the mass of an object, the greater the force needed to move or stop that object. The formula used for Newton's second law of motion is force equals mass times acceleration. So let's think about a demonstration here. Let's pretend that I were going to lay here on my table. Do you think that you would be able to pick me up and carry me across the room? It should be that easy, right? No. Why don't you think you could do it? Well, you probably can't do it because of Newton's second law. Remember, the bigger the object, the more force needed to move or stop it. The smaller the object, the less force needed to move or stop it. I'm probably much bigger than you are, so you would have needed much more force to move me. Now, if we bring a dozen of you or we bring the whole camp along, then you'd probably be able to move me. But we'll save that experiment for another day. Let's take a look at Newton's third law. This law states that for every action, there is an equal and opposite reaction. What this means is if you push on an object, that object pushes back in the opposite direction equally as hard. We're going to make balloon rockets to really observe Newton's third law of motion. For activity 1, we're going to construct balloon rockets. balloons. So we're going to be using latex balloons, just so make sure there are no latex allergies present. For this activity, each science explorer needs a 10-foot piece of string, a straw, preferably cut in half, it'll be easier to get on your string that way, and a balloon, and 2 pieces of duct tape. I know this isn't duct tape, but duct tape would work great. So the first thing that you're going to do is thread your straw onto your string. This straw is going to act as the track for your balloon to travel on. Then you're going to blow up the balloon and you're going to twist the end shut, but you're not going to tie it. We want to try to keep the air in there for now, but eventually we're going to let go and we're going to see what happens. So using the pieces of tape, what you want to do is you want to attach your straw to the side of your balloon. So this activity is going to work best if you have a partner. In this case, I'm going to use my standing desk as my partner. So it is holding the other end of my string. I have my balloon with the open part of the balloon facing me. What I'm going to do is I'm going to let go. I have the string pulled tight, partner's holding the other end, and when I let go, what just happened? The air went this way, right? And what was the reaction? The balloon went in the opposite direction. So this was a great example of Newton's third law of motion in action, right? So for every action, there is an equal and opposite reaction. So that clearly showed us that when we let go of the balloon, the air goes one way and the balloon goes the other way. So for activity 2, we're going to be using the same materials. So you need your balloon rockets from the previous activity. You're also going to need the balloon rocket lab sheet with a pencil so you can keep track of your data. And each group is going to need an additional 2-foot piece of string and some sort of a ruler or tape measure so that you can measure the distance. In the next activity, we're going to work to see if we can record the distance that our balloons travel with different amounts of air inside. So we'll test the distance the balloon rockets travel when they're completely full, when they're 3/4 full, when they're half full, and when they're 1/4 full. So for activity 2, we're going to start with the balloon full. And you're probably wondering, well, how do we know if it's full? Well, this is where your extra 2 feet of string comes in. What you're going to do is blow up your balloon. You're going to hold it shut, and you're going to wrap that string around the center of your balloon so that it meets at the back. So that's going to be 2 feet in circumference, which is all around the balloon, and that is going to be our full amount. So this is going to be the first one that we test. So we're keeping it on the same track that we had it before. Same thing, one partner is going to hold the other end. One person's going to release it from the opposite end. We're going to measure the distance that it travels. So we're going to test it full first. So the person who is really the partner that's releasing the balloon is going to walk to the very end of the string. Okay? And then when you're ready, you're going to go ahead and let go from the very end. That way we'll measure from the end. Okay, and I am going to go ahead and measure the distance to where my balloon travels. When I measure this part of the string, I will know exactly how far it traveled. So checking in on the data sheet, I measured the circumference of the full balloon. It was 24 inches, and you can see that after I measured the distance it went a total of 58 inches that the balloon traveled. So the next thing that we're going to do is we're going to test it at 3/4 full. 3/4 of 24 inches is 18, so I know the circumference of my balloon needs to measure 18 inches this time we're going to measure its distance. Then we're going to repeat with 12 inches, measure the distance, and then finally 1/4 full, which would be 6 inches, and we're going to measure the distance traveled. This time the circumference, or the distance around the balloon, is 18 inches. Go ahead, let it go, then we'll measure the distance. Okay, this time the circumference is 12 inches, so it's half of the original. It went this far. I'm going to go ahead and measure it, add it to my data sheet, and then we have one more to test. And our very last trial is our 1/4 full balloon, which has a 6-inch circumference. Here we go. And I'm going to measure how far it went that time. So let's take a look at our data here. We can see that the bigger the circumference, the more air was let out of our balloon. And check this out, the further distance it traveled. So as the circumference was smaller, the amount of air leaving the balloon was smaller, and thus the amount, or the distance traveled, was also shorter. So we can see that the balloons that had the most air are definitely going to travel the farthest. Those that had the less amount of air are going to travel a shorter distance, which makes sense. There are some optional extra activities if you're interested. You can always tape some pennies to your balloons to see how weight is going to affect the speed of the balloons. And who doesn't love a good race? So if time allows after you're done experimenting, please feel free to hold some balloon rocket races. In this lesson, we learned all about Newton's 3 laws of motions. I hope you feel like you have a great understanding of what those laws mean. I'm Jellyfish Jill, and I'll be back real soon for another lesson.